let's finish up. Chapter 12 is what we're going to cover tonight. So it's systems of equations, and we'll do some systems of inequalities as well. But anytime you're solving a system of equations, no matter how small or how large it is, you got three scenarios that can happen. One of those is that there's one solution, and the real mathy term for that is consistent and independent system of equations. Or you could have infinitely many solutions, which is also consistent, but it's called a dependent system. So consistent means you got answers. Independent means you've got only one answer. Dependent means you've got an infinite number of solutions. And then the third scenario is that there's no solution at all. And that's just called an inconsistent system. So we're going to learn some ways to solve systems, and they're going to occur mainly on the graphic calculator tonight, which is a wonderful thing. So we'll just start with a 2x3 system. Example A, x plus 4y equals negative 14, or not negative 14, just regular 14. And then 3x minus 2y equals 0. So that's our first system. In high school, in Algebra 1, or maybe even in junior high math, is where we do it now. But we also do it in Algebra 1. You learn methods of substitution or elimination to solve those. We get into Algebra 2. We teach matrix operations to solve those, which is what we're going to use. So we're going to use what's called Gauss-Jordan elimination to solve this, which is basically matrix. So what you're going to do is you're going to set up a matrix, a 2x3 matrix, and the coefficients and the constants are going to be your rows and columns. So the first equation, the row that it creates is a 1, 4, 14. And then the second equation creates a row 3, negative 2, 0. So that's a 2x3 matrix. So what we're going to do is we're going to use reduced row echelon, ELON form. So reduced row echelon form, RREF, is what we're going to use the calculator. So we're going to go to the graphing calculator. We'll whip that thing out. And we're going to go to the matrix menu. To get there, you're going to press second, and then the X inverse button, which is that one, just underneath the math button. And we're going to go over to edit, and we're going to just pick one of those matrices to use. I'm going to use the first one, and I need to tell it what size it's going to be. So this is a 2x3, 2 rows, 3 columns. And notice it changes the size as you change that. And then you're just going to put in that row, those 2 rows, just like we've written down. So 1, 4, 14, 3, negative 2, and 0. Once you've put that in, you're going to press second mode to get back to the regular calculator screen. And then you're going to go back to the matrix menu and go over to math. And then you're going to scroll until you find the RREF option. There's RREF is the one you want. REF will reduce it part of the way. Reduced row, the double R there, is the one you want to get you the answer. So we're going to use that one. So RREF, press enter, and then we're going back to the matrix to tell it what to do that to. So I put mine in matrix A, so I'm hitting enter for that. You don't have to close those parentheses. I just do. And there we get this reduced row echelon form of this, which is 1, 0, 2, 0, 1, 3. What that tells us is that x equals 2 and y equals 3. So we get this ordered pair solution 2, 3. That's the solution to that system of equations. using reduced row echelon form. It's called Gauss-Jordan elimination. That's what it's called. So because it uses a matrix. Okay. All right. So that's the way I want you to solve a system of equations. We're going to do a couple more. So get some more practice with that. So 2x minus y plus z is equal to 0. And then x plus z equals 1. And x plus 2y is equal to 8. So this system has 3 variables in it. Even though a couple of the equations don't have all 3, we can still use that RREF and a matrix to solve it. So because it has 3 variables and there's 3 equations, we're going to have 3 rows and 4 columns for this one. So 3 rows and 4 columns because we've got 3 variables, and if we got a column for x's, a column for y's, a column for z's, we need another column for what those equations are equal to. So when you're setting these up, you got to make sure all the variables are on one side of the equal sign, and then all the numbers are on the other. So this one is set up that way. And so we're going to have the first column is going to be x's, the second column is going to be y's, third column is z, and the fourth column is what that equation is equal to. So that first equation gives you this row of 2, -1, +1, and 0. The second equation, we've got an x, so we got a 1 in front of that x, but we don't have a y, so we're going to put a 0 in its place. We've got a 1 in front of the z, and then the whole thing is equal to 1. And then the third equation, you got a 1 in front of the x, a 2 in front of the y. The z is missing, so I'm going to put a 0 in its place. It's all equal to 8. We get this 3x4 matrix to deal with out of that. So we would go to our calculator then, and we would second matrix, go over to edit, and you can put it into a different matrix, or you could put it into matrix A. I'm going to put mine in B, 3x4, and then just put in those rows, 2, -1, +1, and 0, and then 1, 0, 1, 1, 1, 2, 0, 8. And then second mode to get out of there. Then I'm going to second matrix, the math menu, press the up arrow, it's quicker to get there. RREF, and then go pick up the matrix that you put it in. I put it in matrix B and hit enter. It gives you that reduced row echelon form, 1, 0, 0, 2, 0, 1, 0, 3, and 0, 0, 1, -1. And that tells you that x is equal to 2, y is equal to 3, and z is equal to -1. You get this ordered triple, x, y, z, 2, 3, -1. So that's the order that you're going to get those in when you have one solution. So these two systems, A and B, that we've done, they're one solution, or consistent and independent systems. So let's look at what the next one brings into the picture. Example C, here's our system, 6x minus y minus z is equal to 4, -12x plus 2y plus 2z is equal to -8, and then 5x plus y minus z is equal to 3. So again, that's a 3x4 system. We don't get much bigger than that in here. Not going to really help you to get there. Any bigger than that, it's usually just just 1 or 2 rows. bigger. Most of what we do is 3 by 4 for our larger systems. So this is the matrix that we're going to be putting in. And we're going to do RREF to that and get a matrix back. Actually, paste it in the calculator. So second matrix. I'm gonna go over to edit, and I'm just gonna edit matrix B and use it. It's already the right size. I'm just gonna put the stuff in there. Just gotta make sure your signs are all right. One, -1, 3, and then do the RREF to that. Second matrix, and then pick the one you put it in. This one's a little different because you've got decimals in there. So if you get decimals in there, and you need fractions, you hit math, enter, and it'll convert those to fractions. What we've got here though is a matrix that's got a bottom row of all zeros. So when you got that bottom row that's all zeros, that tells us that this one has infinitely many solutions. All zeros on the bottom row give us infinitely many solutions. And with that, we've got to do a little bit of work to write the solutions in a form that they're going to ask us for. So what we want to do is write the solutions in the form of Z. And so they're going to tell you what variable to use, okay? And what you're going to do is you're going to take that matrix, those other two rows, and you're going to use those to write the ordered triple in the form of Z. So you're going to have something for X, something for Y, and then Z is going to be the only variable in those things. So what we do is we take that first row, and the first row, if you convert it back into an equation, it's X minus 2 over 11 Z is equal to 7 over 11. Okay. We need to get X in the form of Z. So that means I need to take that equation and just get X by itself. It's not a hard thing. It's really easy. It just seems difficult. I just add 2 over 11Z to both sides, and I get X is equal to 2 over 11Z plus 7 over 11. 2 over 11Z plus 7 over 11. So that's what X is. That's its form in the form of Z. I'm going to do the same thing for the Y equation. If I take that second row of this matrix up here, the second row there says Y minus 1 over 11Z is equal to negative 2 over 11. That's what the second row in our reduced row matrix says. And all I got to do is just get Y by itself. And I've got my equation. Because Z is the only other variable there. So add a 1 over 11Z. Minus 2 over 11. So 1 over 11Z minus 2 over 11. That gets us our solutions in the form of Z. That's the most common variable to write your solutions in. Even though they could ask you for other forms, that's the form that is most commonly asked for in our textbook, or most any college algebra textbook that I've ever seen. I've seen quite a few. Z is the form that most people go for out of that for whatever reason. It's kind of arbitrary, but that's the way they go about it. So anytime you get infinitely many solutions, they're going to ask for it in the form of a variable. I'm going to ask you for it in the form of Z. That's the way I'm going to ask you for it. So be able to reproduce that out of that. So let's look at one more system to solve matrices. Let's say we had x plus y plus z is equal to 6. 2x minus y minus z is equal to 3. Then x plus 2y plus 2z is equal to 0. So again, a 3 by 4 and your matrix that you're going to put in. It's going to be that one. And see what happens with it. Matrix. I'm just going to edit matrix B again. It's already the right size. And move my paper so I can't see my matrix again. 1, 1, 1, -6, 2, -1, -1, 3, 1, 2, 2, 0. And here's a little trick. Graphing calculator, since you've already done RREF for matrix B, and I put mine in matrix B, I'm just going to arrow up and until my cursor gets onto that thing. You can't see, it's highlighted on my screen, but it's not, you can't hardly see it here. But I'm hitting enter once I get it highlighted, and it just copies that command over, so I don't have to go through the menu to get it. It's probably about the same number of button presses. And when I do that, I end up with what looks like an answer, but it's not quite. Out of that, I've got that bottom row is what tells the tale. That bottom row says that 0, 0, 0 is equal to 1, and 0, 0, 0 can't be equal to 1. I don't know what to do in there. We'll fix it. This bottom row here tells us. Let's squish that a little bit. See it. Good. All right. This bottom row here says, I took the wrong picture, didn't I? I want that picture. Copy. Delete you. Paste you. There we go. That's the right one. Be fancy. All right, now we got the right bottom row. That bottom row there says that 0 plus 0 plus 0 is equal to 1. And we know that never can happen. You can't add 0 up 3 times and get 1 out of it. That right there tells me that this is a no solution system out of that. And there's nothing else to do. That inconsistent system, because the bottom row has all zeros and then another number. It doesn't necessarily have to be a 1 there. Could be any other number, but we know 0 plus 0 plus 0 cannot be anything but 0. So infinitely many solutions, you'll have a bottom row will be all zeros. No solution, you'll have everything but the last piece will be a 0. Okay, so look for those clues for doing that. All right. Amongst the same sections is this little deal. It's just row operations. And this is what your calculator is actually doing when it solves a system of equations. It's doing a bunch of row operations to get it down to that reduced row echelon form. This always comes up on the final, so hint, hint, make sure you can do this. It's really easy to do. It's one of those things you just don't do it in the calculator because it's too easy to do outside of the calculator just by hand. And that's just row operations. And what they do is they give you this matrix. And let's say we had 5, 2, 13, -3, 1, -10. Doesn't really matter what size the matrix is or anything. But they'll say, okay, row 2 is equal to 3 times row 1 plus row 2. What that tells me to do is take whatever row 1 has in it and multiply it by 3, add it to row 2's values that are in the same spot, but only change row 2. So this is the only change. That's what that says. Only change row 2. So when I do that row operation, row 1 is going to stay the same. Even though the row operation says multiply it by 3, the only one that's changing in the final answer is row 2 based on this operation. So this is going to say take 3 times row 1 and then add that value to row 2. So 3 times 5 is 15. Then add that to -3. So 15 plus -3 would be 12. So that's in row 2. So that's the new value for the first spot in row 2. And then 3 times 2 is 6. 6 plus 1 is 7 in row 2 in that second spot. 3 times 13 is 39 plus -10 would be 29. And that's a row operation. And this is the answer, is doing that row operation. If they gave you more than one row operation, you do them in order. Start at the top. Do that, get the answer, then do the next one. Do that answer. And if you gave you 4 or 5 of them, you would do those in order, one at a time. Don't try to do more than one at a time. It gets hairy if you do that. But this is always on the final. Super easy to do. Doesn't take a whole lot of work to do it. And it's always a simple multiply one of them by something, add it to the other one out of that stuff. So I always kind of try to make sure we talk about that. But it's a super easy idea. Just make sure that whatever it's equal to, that's the only one that changes for that row operation. A lot of the big mistake for that is changing row 1 by multiplying by 3. And when you write your answer, you got 15, 6, and 39 there. And that's not what row 1 has in it because it's not changing. It's just being used to change row 2 out of that. So being able to do row operations, that's definitely something that will be on the final. It's been on it every year I've taught college algebra. It was on it when I took college algebra back in 1998. So it's been around a while. So, but that's always on there. I don't know why. They like that kind of problem. I could find much more important things to put on there, but they like putting that one on there. So it's easy to do though. All right. So next section, 12.4, matrix algebra. This is the fun stuff. Everybody loves matrix algebra. It's super easy. Doing it on the calculator is kind of the way you want to go about this. So definitely you can do it by hand. I do a lot of it by hand just because that's how I learned how to do it. But I'll show you how to do it by hand and with the calculator. I do not expect you to have to do it by hand unless you want to. All right, so I'm going to write matrix A is that one. Matrix B is this one. 1, -2, 11, 8, -5, 14. And then matrix C is 6, -4, 2, -1. So different size on that one. Okay. What I would do if I get a problem set like this and it's got 2 or 3 problems that use matrix A, B, and C, I would actually type those into my calculator, matrix A, matrix B, and matrix C, into the graphing calculator. So let's do that. So I'm going to go to second matrix, go over to edit, and in matrix A, when I look at that matrix, what size is it? It's 2 rows, or it's 3 rows, but only 2 columns. So it's a 3 by 2. So I change that to 3 by 2. And the good thing is it shows you what that looks like. You make sure it looks like the one you're trying to type in. So 3, 6, 5, -7, 2, and 10. And I go back to matrix, go to edit, go to matrix B and type in that one. It's a 3 by 2, 1, -2, 11, 8, -5, 14. Get out of that, go back to the matrix menu again. I'm going to go to matrix C this time, and this one is a 2 by 2. And 6, -4, 2, -1. So you put those in there, and then they would give you a problem that might look like this. They might say A plus B. And generally with addition and subtraction, I don't do them with the calculator. I'm going to show you how to do it with the calculator. But I generally just do the math, because addition and subtraction of matrices is super easy. It's just adding up matching places or subtracting matching places. In order to add and subtract matrices, you have to have the same size. So if I'm going to add A and B, they have to be the same dimensions. You got to have the same number of rows and columns in both of them. So A is a 3 by 2, B is a 3 by 2. So that means it's a defined operation to be able to add those together. And you just add the matching spots. So 3 goes with the 1, 6 goes with the -2, 5 goes with the 11, -7 goes with the 8, 2 goes with the -5, 10 goes with the 14. So it's just matching up pieces. So I generally don't do these with the calculator. I just do the math and add them up. -7 plus 8 is 1. 2 plus -5 is -3. 10 plus 14 is 24. Because usually if I'm only going to do that addition, it takes me longer to type it in than it does to just do the math. But if you're unsure of yourself, and God knows if you're on the final, you want a good grade, right? So you can always check that with the calculator. So you would just take matrix A. So just go to the names under the matrix menu, pick up matrix A plus, and then I put that in matrix B, and make sure you got the same thing. You just get under the matrix menu, under the names, pick the ones you want to add together, put a plus sign between them, and you got it. It's going to crank it out. Exact same thing that we found there. Same way with subtraction. If you did B minus A. So 1 minus 3 would be -2. -2 minus 6 would be -8. 11 minus 5 is 6. 8 minus -7 would be 15. -5 minus 2 is -7. 14 minus 10 is 4. That's just doing it by hand. Addition, subtraction, I generally do that by hand. I hardly ever do it with the calculator, just because it takes too long to type it in. But if you already had them typed in, B minus A, and there you get the same answer. So you can always check with the calculator. Very easy to do. Now, what if they gave you this problem and said A plus C? Can that be done? Why not? They're not. Yeah, they don't have the same rows and columns. So that's what you say there is it's an undefined operation, because the rows and columns don't match up. If you forget that for whatever reason and you just said A plus C with your calculator, 1 plus C, it's going to give you an error. It's going to say dimension mismatch. What that means, you don't have the same dimensions. You don't have the same number of rows and columns, and it can't add or subtract those. Okay, so rows and got to match up. Same exact number of rows, same exact number of columns to be able to add or subtract. Okay. All right. Next thing with matrix algebra is scalar multiplication. Bless you. Scalar multiplication, what I want you to think about there is distributive property. What that is it's taking a matrix, and I'm gonna leave the same matrix that we've already got typed in for matrix A. Matrix B. It's the same ones that we just used. I'm not changing them just because it takes longer to type them in. And scalar multiplication would be just taking, let's say I took -3A. That means take -3 and multiply it by every piece inside of matrix A. So that would be -9, -18, -15, +21, -6, -30. Again, just like the addition and subtraction, I usually don't do that with the calculator just because it takes me a long time to type it in, and I can just do that multiplication. But if it were multiplying by like a fraction or something like that, that I wasn't so fast at being able to multiply, and I'm going to have to do a little bit more work, I would just go to the calculator and I would say, okay, -3 times matrix A. Lo and behold, it cranks it out for you. I actually don't think you even have to put the times symbol in there. You could just go -3 matrix A like that. Yeah, you don't have to put the times operation in there. So really, really easy thing. These are give me type things. This last chapter is usually the highest test score of the semester, just because it's if you type it in right, you can get it, which is always a good thing to boost that score right before the final, which I like doing that. They can combine that with the addition subtraction, where they might say 2A minus 4B. Now, when it gets to doing this, I usually will do that with the calculator, just because I don't have. I'm going to have to write a bunch of stuff down or type a bunch of stuff in, one or the other. And I usually will just go to the calculator with that and say, okay, well, that's fine with me. 2 matrix A minus 4 matrix B. And let it do the hard work for me, and it cranks out that result. That's what I would copy and put as my answer. There's that solution right there. 220, -34, -46, 24, -36. Doubling everything in A and subtracting away 4 times everything that was in B. That really, really simple idea of scalar multiplication. Okay. All right. Next thing is, so we've done addition, we've done subtraction, we've done scalar multiplication. The next thing is multiplying matrices. Multiplying matrices is a lot more complicated than the other things that we've done with matrices so far. So complicated that I do not recommend you doing it by hand, because there are so many operations involved that it's very easy to make there's a lot of opportunity to make mistake with. When I took linear algebra, which is a 300 level class, at UTM, we weren't allowed to use a calculator. You had to do it by hand, and it's quite extensive. when you try to multiply two matrices together, because you're taking all of the rows of the first matrix times the pieces in the columns of the second matrix, and if you take a 2 by 3 times a 3 by 4, you're ending up doing, let's see, 2 times 2 is 4. 1, 2, 3. Man, that's 4. 4 per piece. So that's 1, 2, 3, 4, 5, 6. 6 times 4. It's 24 operations in order to do it by hand, which you don't want to do. What's got to happen, though, to make multiplying matrices a legal operation is you've got to have the columns in the left matrix have to match the rows in the right matrix. Okay, so you have so left matrix and right matrix. So when you're doing multiplication with matrices, it's not commutative like regular numbers. You know, regular numbers, 2 times 3 is 6, just like 3 times 2 is 6. Matrices, it's not that way. Whatever order they're in, that's unique. Okay, so left matrix, the columns in the left matrix have to match the rows in the right matrix to be able to multiply them together. If they don't match, then it's undefined, just like with the addition and subtraction. Just an undefined operation. So if we had a matrix A, so I'm changing up what matrix A is. Matrix A is 2, 4, -1, 5, 8, 0. And matrix B is 2, 5, 1, 4, 3, oh, not 3, 4, 8, 0, 6, -3, 1, -2, -1. All right, so we have a 2-row by 3-column matrix. Matrix B is a 3-row by 4-column matrix. Okay, if you're going to multiply them together, example F is A times B. That is taking a 2 by 3 times a 3 by 4. The numbers in the middle, remember, have to match. These do match. What that's going to equal is a 2 by 4 matrix. Okay, that's the size that our answer will be. Okay. Again, I don't recommend that you multiply this by hand. If you want to know how, I can teach you how. It's just taking 2 times 2, 4 plus 4 times 4 is 16 plus -1 times -3 is +3. So 4 plus 16 plus 3 would be 4 plus 16 is 20. 23 is the first piece. That's just one answer. You got to do by 4, so that's just the first element in the first row. And then you got to do that again. You got to keep doing it. You got to do all the calculations and stuff. It is a pain to do it by hand. Get used to it, get faster at it the more you've done. I've done a bunch. I don't know how many it's been, but it's a lot over the years. My suggestion is just put it in the calculator. You guys are not, most of you, you're not looking to do this. If you are going to go into a math field like an actuary or something like that, you're probably still not ever going to do them by hand. You're going to use some sort of technology to help you out of that. If you take linear algebra or if you go into engineering, you might encounter having to do some of this by hand, but most of the time now we're using some technology to do this and getting a little bit better at that. So what we do is we go to the matrix and we edit matrix A. It's a 2 by 3, and I'd put in that matrix 2, 4, -1, 5, 8, 0. And then get out of that, go back into it, go to edit. I'm going to edit matrix B, and this one is a 3 by 4 this time. So we got 2, 5, 1, 4. 4, 8, 0, 6. -3, -1, not -1, +1. If you can't type it in right, you won't get it right, that's for sure. So, and then -1 on the end. So check all your signs and numbers, make sure they're matching up, and it looks like I've got it okay now. And then you do A times B. So second matrix A times second matrix B. And again, we get that 23 is the first spot, but then you've got 7 other spots you got to fill in. So that's the matrix that is the solution to that problem. And multiplying matrices definitely is a calculator activity in my world. I don't even make my Algebra 2 students in high school do it by hand. It would just be frustrating. All right. Another thing that's a calculator-driven activity is an inverse matrix. An inverse matrix, there's no such thing as matrix division. It does not exist. You cannot divide by a matrix, but you can multiply by its inverse. So this is our kind of our ticket to being able to, when we would normally divide a number, we can use the inverse. Dividing is the same as multiplying by a multiplicative inverse in regular numbers. Inverse matrices, my biggest thing for you to do is just be able to find an inverse matrix. And an inverse matrix only exists for square matrices, and it doesn't exist for all square matrices. Okay, so here, this is a square matrix. A square matrix is the same number of rows as the same number of columns. Okay, so this one's a 3 by 3. You could do the inverse matrix for a 4 by 4, a 2 by 2, a 75 by 75. It's all the same process. If you're going to do this by hand, it would take a large number of row operations to do that, and it doesn't get pretty until the end. So it's very tedious to do that. So I don't expect you to do it by hand. I'm not even going to show you how to do it by hand. I'm going to show you just calculator wise. You're just going to go to the matrix, second matrix, and you're going to go to edit, and I'm just going to put in matrix A 3 by 3, and I'm going to enter that one that we just wrote down. 1, 1, 0, -1, 3, 4, 0, 4, 3, and get that in there. Go pick up the name of that matrix, and then the inverse button is the 1, 2, 3, fourth one down there. It's the same one that you hit second to get to the matrix menu. Just don't hit second this time. Get that little -1 exponent. That's what you want. That's the inverse. And hit enter. And I'm going to change it to fractions. And that is the inverse of that matrix. This is A inverse. Be able to find the inverse matrix. I'm not going to do any solving equations with that or anything, so just be able to find an inverse matrix. That tends to come up some on the final exam as well. They like for you to be able to do that. If you're a Braves fan, they've re-signed Brian McCann. I called that about 2 months ago. So if Boston wins, then Braves re-sign him. They did. did. So he's going to retire as a Brave. That's the whole point. All right. Last real algebra thing that we're going to do here is dealing with systems of nonlinear equations, which takes us out of being able to work with a matrix. Matrices are used in linear systems. Nonlinear systems, we want to be able to do some algebra type things to get there. So let's look at section 12.6, nonlinear systems. It's a systems of equations, so it's still got the same possibilities. We can still have one solution, infinitely many solutions, or no solutions. The difference is the one solution could be more than one point, depending on what kind of equations that we have. So let's take a fairly simple one to start off with, or a simpler one to start off with. I don't know how simple you call this, depending on how good you are at the stuff. All right, so here we have a linear equation, 3x minus y equals -2. That's a linear equation. And the second equation is quadratic. So we have a linear and a quadratic. So if we were to graph this, and we're going to, I'm going to show you how to do this with the calculator, not do so much algebra work, but a little bit more calculator work. We're going to take, we would have a straight line and then a quadratic. It would look something like that. It's going to look something like that. How many places does that linear equation, that blue one, cross the quadratic? Twice. Okay, so you've got a linear, and it could cross that twice. It doesn't necessarily have to cross it twice, but we're looking for two places that it would be crossing. So what we're going to do is we're going to end up graphing these two. So to graph the linear problem, we need to get y by itself, right? So I'm going to try to get that in slope-intercept form. So I would subtract 3x, negative y is equal to negative 3x minus 2, and then I would divide everybody by -1. Just good old Algebra 1 stuff. So I would have this equation, y is equal to 3x plus 2. And then the second one, I'd do the same idea. I'd get y by itself. I have negative y is equal to negative 2x squared plus 0. Then divide by -1 again. And there is 2x squared. So these are the two things that we're going to graph and find out where they're crossing. Okay. So graphing calculator, I'm going to hit the y equals button. When you do that, make sure you don't have any scatter plots turned on or stat plots. So make sure your plots up there in the top are not darkened in. If one of them is darkened in, like that, then press the arrow up and just hit enter, and it'll turn it off so that it's not graphing it, because sometimes that can cause problems with us graphing equations. So we're going to graph y equals 3x plus 2, 3x plus 2, and then 2x squared. We're going to graph both of those at the same time and see how many places are they crossing? 2, right? Looks like one is just to the left of 0, and then one of them is close to +2, somewhere around there. We're going to use the calculator to help us find that exact point, or a decimal approximation of that point, if necessary. So I'm going to hit second and then the trace button to get to the calculate menu. All right. What are these two graphs doing? They're intersecting. So we're going to use number 5 to help us find that. Okay. First curve, I'm going to move to the left of where they cross. And when it asks me to guess, and I'm just going to hit enter on the second curve, and then it's going to ask me to guess. I want to move to the one close to the one that I want because they're crossing in two places. So when you hit guess, when I ask you to guess, you need to pick the one you want to find. So the first one is at negative 0.5 for the x value and a positive 0.5 for the y value. X equals negative 0.5, y equals positive 0.5. So there's one. It's an ordered pair if you really get technical about it. And then let's use the calculator to find the other intersection of that. So I would hit second trace, and I'm going to back to intersect. First curve, second curve. Now when it says guess, I'm going to move my cursor up here close to the second intersection. Doesn't have to be right on it. It's just got to be close to it. And there we have the intersection at 2, 8. Ordered pair would be 2, 8 out of that. So if we can graph them, we can use the intersect tool to find where they're crossing one another at. So that's what our job is going to be for nonlinear systems. Matrix would be nice, but the matrices do not work for nonlinear systems. So you got to be careful of that. Systems of inequalities. Let's look at that real quick and talk about how that works. So this is section 12.7, and I'm actually going to graph some stuff on paper to show this to make sure we remember how to do that. So page setup, and grab some graph paper here. All right, so 12.7. Systems of inequalities. We'll start with one that's just linear, but the graph is the actual answer. You're not going to get an actual one single ordered pair as an answer. You're going to get a graph that is the answer to this one. So here we have y is greater than 3x minus 7, and then y is less than or equal to negative 1/2 plus 5. So what we're going to do is graph that on a coordinate plane and then shade it so that we can find the solution area. So if I graph this first one, graph it with blue, I'd go to negative 7, 1, 2, 3, 4, 5, 6, 7, and up 3 over 1, up 3 over 1, up 3 over 1, and make that a dotted line because it doesn't have the equal to mark. Remember, graphing systems or graphing inequalities. If it doesn't have the equal to mark at the dotted line, and then to shade it, if it's greater than, you're going to go where the y values are larger, which would be up to the left of that line. So I'm going to shade, I'm going to use a yellow marker. So this side of that line. You could also use a test point if you're not sure about that. The test point that you could use here would be the origin 0, 0. When you plug those x and y values in for x and y in the inequality. Is 0 bigger than 3 times 0 minus 7? Yes, 0 is bigger than negative 7. So we would shade that side. If it were false, we would shade the other side. And then we're going to go graph the second inequality. It's not showing the red. Y-intercept of 5. 1, 2, 3, 4, 5. Negative 1 over 2. Let's do that a few times. This one is a solid line because it's got the equal to mark. And then the shading is less than, so that's going to go down below that. So that would be this side of that line. And my solution area, you cannot see. That is unfortunate. Let's shade maybe pink. Yeah, you see it. This is the strangest projector because I'm shading in pink and the overlap is red, and you guys are seeing blue and black. So the weirdest thing. You don't see it. That is the weirdest thing. I don't get it. But anyway, oh well. Anyway. Solution area is the overlap. So this is the solution area. That's what we're finding. The graph is our actual answer out of this. If you want to graph inequalities with your graphing calculator, it can be done. There's an app that does it, but I'm not supposed to show you how to use apps, so I'm not going to. But if I'm going to graph 3x minus 7, what I can do is press the left arrow key until I get to the left there. And if you got the color one, you get the option of just arrow above, shading above it or below it. Above it is the triangle that looks like this. That's the triangle that says shade below it. We were shading below that line. So hit enter and it'll, no, we shaded above that line, didn't we? Sorry. Back up. There we go. Yeah, I didn't change it. Gotta hit enter. Pain. All right. Okay. Now hit graph. There we go. There's the shading on that first line. And then the second one, you go to -1/2 x plus 5. And then we were shading below that line. Hit enter. And there we go. Okay. Hit graph. And there we see basically the same picture we were making with that. You can use that to kind of get you a good idea of that. With nonlinear systems of inequalities, exactly the same thing. Let's try this system. Y is greater than or equal to x squared minus 4, and then y is less than or equal to -x plus 2. I've got y by itself on each inequality. That's what I want. And then I want to graph that with the, I'm going to use the coordinate plane here. X squared minus 4 I know is a parabola. It's a quadratic shape. It's got a y-intercept at -4. If I plug in a 1, I get 1 squared minus 4, which would be -3. Plug in -1, I get the same thing. If I plug in 2, I get 0. So I can get a pretty good picture of what the graph is doing. It's a solid line because it has an equal to mark. So this is the shape that it's taking. My graph's not going to be perfect, but it's going to be close. And then the shading above that is going to be inside of the inequality or inside of the parabola. So I'm going to shade inside here. Like that. Oops. Yeah, I shouldn't have got so. That. So if that line continued, it would still keep the parabola shape on the edge. And then I would go and I would shade and graph and shade this one, y-intercept of 2, slope of -1. Solid line because it's got the equal to mark. Less than goes below. So that shape in the middle there, that's our solution area. So our solution area is here. Not a difficult thing, but if you're going with the graphing calculator, same idea. Y equals do the x squared minus 4 here. So x squared minus 4. I'm shading above that one, so so I put it there, and then I've got negative x plus 2. Delete this other stuff. Hit graph. There's the same picture. The shading on the graphic calculator. All right. The one we've been looking for. The last page of the semester, kids. My favorite one. Try to make this as easy as possible on this. I don't try to kill you with the linear programming, because it can be tough. I'm not gonna make it tough on you. Okay, it's the last thing of the semester. Why would I kill you on this? You're gonna have what's called an objective equation. I'm gonna give that to you. This objective equation is I equals 0.02x plus 0.03y. I'm going to give you that objective equation. Okay. You'll have these things called constraints. Constraints are what creates a polygon. And in this one, the constraints are x is greater than or equal to 0, y is greater than or equal to 0, x plus y is less than or equal to 25, x is greater than 15, and then y is less than or equal to 5. Those are all those constraints. In some instances, you might have to graph all of those on the same coordinate plane. Okay. For me and my test and my quizzes online, you're not going to have to. I'm going to have it already graphed for you. That way you're using the same picture. So here's the graph would end up looking something like this, where you would have all of these lines drawn. And I'm just going to rough it in here and get kind of close. It would look something like this, and the shading would all overlap in this trapezoid shape right there. Okay, what you're looking for are the corners of that trapezoid shape or that polygon shape. Whatever the polygon where the shading all overlaps, you're looking for the corners. Okay, you need the ordered pairs for all of the corners. Okay. Those ordered pairs are what you're going to check in the objective equation. Okay. So what I'm going to do is I'm going to take each of those ordered pairs, 15, 5, 15, 0, 25, and it doesn't matter what order you check them in, and then 25, 0. I'm just writing them in some order. And I would plug those in to the objective equation. And get the value for that. So again, 15, 5, I plug in 15 for x, 5 for y, and work that out. 0.02 times 15, 0.03 times 5, and I work that out, and I would get 0.45 if you type that all in your calculator. Again, I definitely. And then that's x is 15, and then this one, y is 0. So that'd be 0.3. This one, we're plugging in 20 for x. And 5 for y. So it would be 0.4 plus 0.15 would be 0.55. On this one, you're plugging in 25 for x and 0 for y. You get 0.5. What it will ask you in the problem, these are kind of in the context of word problems, it's going to ask you for the maximum or the minimum. sometimes it'll ask you for both of them. The maximum for this one would be 0.55 at the ordered pair is 25. The minimum would be at 0.3 at the ordered pair 15, 0. Minimum is the lowest value for your objective equation. Maximum is the highest value for your objective equation. So that's what I'm going to ask you for this stuff. For me, again, on the test and the Canvas quiz, I'm going to give you that stuff. Okay, I'm going to give it to you. You're not going to have to find it on your own. All right. On the final exam, if they have one of those on there, they usually don't, but that doesn't mean they won't this time. I will adjust from there. Okay? It may be that I write it on the board what ordered pair you should or something like that. But anyway, so that ends our semester of stuff as far as new material goes. There are 2 separate Canvas quizzes for this, because I normally would teach this, half of this on one night, half of this on another night, and probably go a little bit more in depth to each one, just more examples of it. But due to canceling class for the storms the other night and Thanksgiving break there, we just did it all in one night. I'm going to still have 2 separate Canvas quizzes that you'll do. They're 2 smaller ones. So that should kind of help actually be able to do that. And then this week I'll send out those Canvas quizzes, a review for the test that's next week. Next week we'll come in 4 o'clock, take our test, just normal time. And then I'll also try to send out practice finals this week so that you can start working on those. And that way, if you've got questions, you can get those emailed to me and I can get you a response. And hey, you'll be ready for that final exam, which will be the December the 10th. And we will start at 4 o'clock and you will have until 6 o'clock. So it's a time 2-hour final. We'll start at 4, got till 6. My next class, theirs will be after you guys. Does anybody else have a final that day? If you got another class, usually they send out a thing where I've got to fill out a form to make sure that time is okay. And Dr. Deere checks it to make sure nobody else's departmental final or anything is that way. Usually it's not an issue, but I just want to make sure. If you find out this week that one of your other classes is having a final anytime between 4 and 6, let me know and we'll try to figure out something for you, because I've got another class that's taking a final after you guys, so that would, you'd be able to stay and take it later if you needed to. But let's hope to get it knocked out at 4 on December the 10th. So Canvas quizzes this week. If you got questions, email me. And then review for the test, review for the finals, also coming to you this week in a Canvas announcement. And we're finishing up this thing, land this bird, and move on with our lives. All right. I appreciate you being here. Y'all have a great week. If you got questions, email me and I'll get back to you.